Moving right along. Let's move into our arc length and the area bisector, which is really just a memorization game. Yeah, let's go into it. Here we have it. We're going back to our definition of a radian, right in here. This is our definition of a radian, that radian is equal to the arc length divided by the radius. And that's going to be equal to our angle. Well, I got them all listed over there. S, which is in purple, is our arc length. R is the radius, and the theta is the angle in radians, not in degrees. Not in degrees. I'm going to repeat it one more time. Not in degrees. Cool, so I thought, can we do a little bit of fancy algebra? I mean, it's going to be a rough one. Theta is equal to S divided by R. All I'd like to do is clear the denominator. I'm like, I don't want any fractions. You can understand that, right? Not wanting fractions. So, you get a fraction, that denominator the heck up out of there. You multiply both sides by it. Goes away. And now you have S is equal to R times theta. Or R times theta is equal to S. We turn it around because multiplication is commutative. And here is our fancy new formula. The arc length of a circle or of a sector, of a slice of pizza. How long is the pie crust on your pie? It's equal to the radius times the angle in radians. And here it is. Here's our definition. For a circle of radius r, a central angle theta intercepts an arc length s given by s is equal to r times theta, the length of a circular arc, where theta is measured in radians. That's the trick to these problems. That is the trick to the problems. That's the trick to the problems. It must be in radians. So let's go find the length of our arc right down here. Here it is. We have a circle with radius r. Oh, but r is equal to 4. So I'd like to just jump aside and just write it down. R is equal to 4 because we have this formula, right? S is equal to r times theta. That's our new formula now. And we just want to fill it in. And we have the theta, right? We go to our next thing. We're like, what other information do we have? We have theta is equal to 240 degrees. And then we're looking for our arc length. That's what we're going for. So we have 3 pieces of information that one piece of information we're given, or we want, and 2 pieces that we're given. The only issue we have is right here. Well, we can't be in degrees, so we must convert that into radians before we're allowed to use our formula. Okay, so for us to go find our S, well, we already have that the radius is 4. We're still left with figuring out, shoot, we have to take this 240 degrees and we need to convert it into radians. So we're going to multiply by that pi over 180. And we do our conversion. The degrees go away. And now I'm going to start jumping these steps. The zeros go away too. You have 24 pi over 18. 24 is 6 times 4. 18 is 6 times 3. So the 6's just cancel straight away and leave you with 4 pi over 3. So it appears that 240 degrees is the same thing as 4 pi over 3 radians. See, you need it. So we replace that in because it must be in radians. It can't be. It just can't be in degrees. It won't make sense. So 4 times 4, remember all whole numbers are over 1 when you multiply. 4 times 4 pi is equal to 16 pi. And our denominator is 3. So since this was, there was no units. If this would have been 4 inches, we would have wrote 16 pi over 3 inches. And that would have been our solution. And if you were to punch it into a calculator, say it was to ask you to round it, you would get approximately, 16.76 inches. That would be the approximation. So this here is exact. When I ask for an exact answer, that's what I mean. This is not exact. It's rounded, and you can tell by the little squiggly lines I use. So there it is. We found a freaking arc length. Now let me show you something where this happens a lot when I get answers. I'm just going to kind of jump over to the side. Now I'm going to make a Make a quick circle. Quick circle. All right. Boom. Dope. So let's make say it's got a radius of 1. Radius of 1. And let's say we're going to take an angle, and I want to see, I want to know what the arc length is for this angle, this little Pac-Man looking thing where this degree is 330 degrees. So you got a 330 degree angle in there. You got the radius is equal to 1. The angle is equal to 330 degrees. Now I'm going to do this wrong. Okay, I'm purposely doing this wrong. You're going to be telling me. I'm going to write in pink here and say S is equal to R times theta. Well, I mean, that's right. I mean, there's nothing wrong with what I wrote there. But let's just say that the radius is 1, and we're going to multiply it by 330 degrees. So the length is going to be 330 degrees. Are you serious? You're just like, yeah, degrees work. Degrees are a length. Huh? Hey, how far to school do you got to go? 330 degrees. It's an angle, it's not a length. What are you talking about? And let's say you were just to ignore this. And you're just like, yeah, 330, and I'm going to call it inches now. So, you're trying to tell me that this is 1 unit long and that this is 330. If you believe that, I got some property I'd like to sell you. So send me a message and I'll hook you up. Right? That doesn't make any freaking sense. That can't be true. We'd have to do the little combination. We'd have to mess with this thing. We'd have to change 330 degrees into what it equals, which happens to be 11 pi over 6. And, sorry, this is without showing you, it's 11 pi over 6. So we would actually have to go through and take this thing and go 1 times 11 pi over 6, which would be equal to 11 pi over 6. And if you were to do the math on that, what is that, 11 times about 330, so that's approximately, I don't know, about 5-ish. 5-ish. That makes a little bit more sense than 330, huh? All right, now let's move into our area of a sector. It's just another formula. Usually, if you were in class, to do the whole formal proof for you. But screw it. We're not gonna. As long as you want to find the area of a sector, it's just the area that is inside of here. It's the area, like look down here, we got a little example problem we're going to go check out, which is saying, well, what is the area of where this sprinkler is spraying all of its water? All right, we're going to find the area, like who got the bigger slice of pizza? That's what I'm always arguing about. I'm a pig. So, if we want to find the area of the sector, how big your piece of pizza or piece of pie might be, we have a formula that says the area is equal to 1/2 the radius squared times the angle in radians. In radians. So why don't we go find out what the square footage we got of this bad boy sprinkler that can shoot 70 feet. We'll use our fancy formula from up here. It says the area is equal to 1/2 the radius squared times theta. Well, now we need to look down here and say, like, well, this is spraying in like a circular motion. Well, this 70, that sure as hell, that's got to be the radius. And then we have an angle, which we're going to need to change up, and that's going to be 120. And that's everything we need to know to go get our area, right? We just needed the radius and the theta. The square will handle itself. The 1/2 will handle itself. Let's go get our area, but first and foremost, we have to be able to change our angle into radians. So 120 degrees will multiply by that conversion factor, which is 1 pi over 180. Let's lose the zeros and the degree symbol. Put it all together, we get 12 pi over 18. I think 6 times 2 is 12, and 6 times 3 is 18. The 6's go away and just leave us with 2 pi over 3. That's better. That's what we should be using. So we have our theta is 2 pi over 3. Our radius is 70 feet. Punch that shit on into your area formula and we got it. So the area is equal to 1/2 our radius squared, which is 70 all squared, times 2 pi over 3. We get some big old freaking numbers here. They're not too bad. If you punched it into your calculator, you would find out that you'd get about 4,900 pi all over 3. That's where we would go, because those 2's would just cancel straight away. 70 squared is 4,900, just left with a 3 in the bottom. But since we're dealing with feet, and it's an area problem, we got to talk about square feet, right? You wouldn't rent an apartment that was just 600 linear feet, would you? That's how you measure a fence. Square feet, get you that square footage. And if you were to actually go and punch this into a calculator, maybe you're curious, like, how much is that? It's about 5,131 square feet. Okay, so there's the approximation. There's the arc length. There's your area of a sector. I'll give you my word on this one. This will be the shit you forget on your final. We teach it to you right at the beginning, but it's uber important. And I have some tricky ways of asking you these questions. So once we get closer to a test, I'll get you out some of the more tricky problems that aren't as straightforward. Maybe I give you some other pieces of information you got to go solve for the radius or something. Okay. I think that about does it. We'll see you.